Hi there, this is Space Nuts, where we talk astronomy and space science. Every couple of episodes, we hand it to the audience and we answer their questions. Well, we pretend to. We just take the questions and basically ask more questions. But on today's episode, we will be talking about those strange noises that are heard on spacecraft. We recently talked about the Boeing Starliner and some of the weird noises coming from that. Well, apparently there have been others, according to Seth. He wants answers, so we'll see if we can figure that one out. Binny has come back to us saying he doesn't believe in the Big Bang. He has another theory, which we will discuss. Jacob wants to know what happens if you tilt a planet off its rotation and whether or not it could become a planet-sized gyroscope and drag everything along with it. And electromagnetism is Nate's topic of discussion on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here with the desire to decipher is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Good to see you again.
Good to see you too.
Yes.
I'm still wearing the same shirt. See, I told you it's the only one I've got. There it is.
Enough. So am I.
Yeah. Weird.
I've got two shirts.
Now, we've got a bunch of questions. This first one comes from Seth, who is from Rhode Island in the United States. Seth says, on episode 451, you spoke of noises on Boeing Starliner that were chalked up to audio feedback. However, there have been two reported similar events. Ellison Onizuka in 1985 on Space Shuttle Discovery. He reportedly mentioned hearing strange knocking or metallic sounds while in orbit. A similar story is tied to a Chinese astronaut, Yang Liu or Li Wei, who reported hearing unexplained knocking sounds during his 2003 flight on Shenzhou 5. How were those explained? What are your thoughts, Seth? I think I've figured it out, Fred.
I'm glad you have.
Yeah, ever since that first story about the Boeing Starliner, I've been wondering. I think it was Sandra Bullock.
Oh, really? Yes.
Yeah.
That would answer the question, wouldn't it? Because that was an obvious answer. Yes. Let me in.
That's what I reckon.
Yeah.
Should that not be a plausible theory? What else could it be?
Well, I didn't actually know about those earlier episodes of noises coming from spacecraft, so I'm really glad that Seth raised our awareness of them. My guess is it could be the same sort of thing, though, because feedback loops occur all over the place and can produce some very strange acoustic effects, as with the Starliner. And occasionally you and I get feedback loops that don't do us any good. They don't sound like knocking noises. They usually sound more like repeated sentences or something like that. But I would say that would be a strong contender for what they might be. Other than that, if you hear some regular noise coming from within a spacecraft, it's clearly not just a single. You haven't hit a micrometeoroid or something like that.
Yeah.
It's something with a bit more repeatability to it. So a feedback loop would seem to me to be the best way to explain it.
The description of the noise on the Chinese spacecraft that Seth mentioned was described as the sound of a hammer hitting an iron bucket. It doesn't sound like feedback. It does sound like Sandra Bullock. It doesn't sound like feedback. And if it's happened more than once, but now the story I've read is they never found the source of the sound.
Okay.
So that makes it easy for us to answer Seth's question in that regard. We don't know because they don't know, but it is a documented incident. Yeah.
In earthly circumstances, the thing that sounds most like somebody hitting a bucket with a hammer is when you get a water hammer in your pipes at home. I don't know whether you've ever had a water hammer, but I certainly have. Yes. And it's quite... It sounds quite terrifying, actually. It's as though somebody's battering the house with a battering ram. Now, there will be fluid pipes on board spacecraft. Whether you could get a fluid hammer set up like that, I don't know. But it's that sort of thing. Again, that's a sort of feedback loop. It's a kind of resonance of the pressures within the pipework. So,
yeah, could be that. I'm trying to find the other spaceship that he referred to, but 1985 it was, so that's going back a fair way. But yeah, there have been metallic sounds reported on several spacecraft that have been logged since 1961. So yeah, it could be the water circulation system. It could be the toilet.
But some of those early ones didn't have toilets.
Yeah, you just had to do it in the suit. Yes, well, that'd make grinding sounds. I'm pretty sure of that. But it's a good theory though, Fred. I don't think they've ever really figured them out, except for the Boeing Starliner, which they did put down to a feedback loop through the audio system. So yes, Seth, we can't give you an absolute answer on that, but Fred's theory could hold water. Yes, I'll still side with Sandra Bullock, though. Thanks, Seth. Great question. Let's go to our next question from Binny.
Hello, Professor Watson and Andrew. This is Binny Matthew. I'm a maintenance engineer by profession. I accidentally started listening to your podcast, and I love every episode of it. Since then, I've never stopped listening to it. It gets me out of boredom when I'm working alone in my department. I love your show. Keep up the good work. And my question is, I don't believe in Big Bang. I don't think the universe started up just by a Big Bang. No matter whatever the cosmic wave background evidence shows or whatever it is, but I don't believe in that. Maybe if you look at the astronomical things, everything rotates everything. So I think the universe is like a planet which is rotating a big massive black hole, which may explain the dark energy or the dark matter. Can you put some light on it? Thanks for getting me to give you the questions, and love your show. Thank you.
Thank you, Benny. If it's a large black hole, no, we can't put any light on it. I'm just going to say something tongue in cheek. It's not an insult, but it reminds me of an old joke that a comedian told years and years ago about a player in the Indian cricket team whose name was Binny. And he referred to him as Rubbish Binny. And I was just going to say, your question's rubbish, Binny. But I'm just kidding around.
It's all right. It doesn't mean it, Binny. It doesn't mean it.
No, I don't. No. Billy Birmingham was the comedian's name. He used to do these augmented cricket commentary comedian things, and he altered all the names of the players. So they were a little bit insulting, and there was one player in the Indian team that he used to call Rubbish Binny because his name was Binny. So anyway, I thought just as soon as I heard Binny's name, that popped into my head. Sorry about that. So no Big Bang. And Binny said he accidentally found us. That's how everyone finds us. No one actually tries to find us on purpose, Binny. It's just not done.
But it's lovely that you've become a Space Nuts aficionado, yes, Binny. So welcome to the family.
No, he's just left us. I've insulted.
Probably after all that, I wouldn't be surprised.
No Big Bang, but a big black hole at the centre of the universe that we are rotating around. I think it's what
it's interesting thinking. I do think anybody who throws away the Big Bang has got to have a plausible explanation for the cosmic microwave background radiation.
I knew you'd go there.
Yeah,
Knew it.
Yeah, well, yeah, it's where you'd go. You're a cosmologist as well, Andrew. You know the answer to all these. When I was at school, in the early 60s, it was an open
It's the
question.
1860s. Sorry, go on, Brett.
Well, yes, actually, that's what it felt like. There were two competing theories for the universe. One was the Big Bang theory, which was not new, but had been postulated in the late 20s and early 30s. So 30 years before or something like that. There was the Big Bang theory, but also the steady state theory. And the steady state theory said that the universe is expanding, but it never had a beginning. And space is being created all the time, and matter's being created all the time. And it was espoused by some big names in the world of astronomy and astrophysics. One of them was Professor Sir Fred Hoyle, who was one of the most notable physicists of his day, astronomers of his day, and actually a leading light in creating the Anglo-Australian telescope. He was the person who first greeted the Prince of Wales, the then Prince of Wales, now the King, when he turned up to open the telescope in 1974. So a very big name, but an aficionado of the steady state theory. And in fact, it's due to Fred that we have the term a Big Bang, because he mocks it on a BBC radio programme, which later turned into a little book. It's up on the shelves behind me there.
Yes, it.
Yeah, I'm glad you did. And he quotes that, the Big Bang in inverted commas. They call it the Big Bang. But what clinched the Big Bang was just a few years later, 1966, if I remember rightly, was the discovery of this background of microwaves from the whole sky, which had been predicted by people who were believed that there had been a Big Bang theory. So the cosmic microwave background radiation is what knocked the steady state theory on the head. There are still a few people who espouse it, and maybe Binny is one, but it's very hard to explain the cosmic microwave background radiation.
Somebody opened the door before they stopped cooking?
Oh, that's what usually happens. That's the old Periton theory as well, yes. From Parkes. But there are some modern scientists who do espouse the idea of the universe being a black hole. So it's I think Roger Penrose is one. His theory says that I think he still has big bangs in them, though. I think they're exploding black holes, but basically everything's a black hole.
Yeah.
So it's interesting to hear your thoughts, Binny, and take no notice of the awful things that Andrew says about people's names.
Fair point, but maybe he can go back and start digging up some proof, and we'll talk about it again. I'm sure
that's it. So again. The question is always, where's the evidence?
Where's the evidence? Yes. Thanks, Benny. Great to hear from you. Don't let anything I said stop you from asking questions again in the future, please. Lovely for you to have contacted us. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a little break from the show to tell you about our new sponsor, Saily. Now, as you're probably aware, my wife and I have done a fair bit of travelling in recent times. One of the pitfalls we find is internet access, especially when we're out and about and we want to stay in touch, or we want to send a photo to the kids, or we want to do a Snapchat or something like that. Most recently in Turkey, we bought international roaming from our current carrier, which was not cheap. And we did the same some years ago with our previous carrier, which was even more expensive. I mean, some of these things can run in at $10 a day, which is an awful lot to pay for very limited services. So what's the better option? The better option is to buy yourself an eSIM from a company that specialises in overseas internet connectivity, and that is Saily. SAILY. Now, SAILY is an organisation that's available through 160 countries and 8 regions around the world, which gives them a very strong presence. It's also not expensive. If you're travelling internationally soon and this is something you'd like to get hold of, bearing in mind there's a big discount at the moment for Space Nuts listeners, just download the SAILY app on your device, whether it's Android or Apple. Choose your plan and don't forget to use the code word Space Nuts when you're ready to pay, and you'll get a 15% discount. That's the SAILY app. Download that on your device. And they have 24-hour, 7-day-a-week support. And if it doesn't work, you'll get a full refund. But they're pretty sure that you'll get the best out of their service. So if you're travelling soon and you need access to the internet via a carriage service in another country, this is the way to do it. Download the SAILY app today, choose your plan, and don't forget the Space Nuts code word for that 15% discount on the SAILY service wherever you're going in the world. I'm sure you won't be disappointed. It's backed by NordVPN, a great company that backs its products 100%. Find out more about SAILY in our show notes. Now, back to Space Nuts.
3, 2, 1.
Space Nuts.
Our next question comes from Jacob, living in Sydney. I think that's his name, not where he's from. As we can see, despite space being 3D, a lot of our space tends to prefer being 2D disks, whether it be a galaxy or a protoplanetary disk. My question is, would these disks act as gyroscopes? Let's say I rotate Saturn 90 degrees about its axis that aligns with its disk. Would the disk follow and eventually lie on the extra 90 degrees, or would it be unaffected? I think I know what he's saying. So you've got Saturn, you've got the disks. If you tilt the planet, does the disk follow in a gyroscopic manner?
Yes, so it does actually, to answer the last part first, but it's not to do with gyroscopic forces. And galaxies, for example, don't exhibit gyroscopic forces because they're not solid objects. They're just individual objects orbiting a center of the galaxy. But with planets, so if you did tilt Saturn on its side and it kept on rotating that way, so its axis was basically pointing towards the sun, for example, what would happen to the rings? Eventually, the rings would follow it because it's the fact that Saturn is rotating, which gives it an equatorial bulge. Its shape is something called an oblate spheroid, so it's fatter at the equator than at the poles. That means that the gravitational pull is very much orientated towards the equator, and that's what pulls the rings into an equatorial orbit. And again, the rings are made of they're solid objects, but the rings are not solid objects. They're made of individual particles, gazillions of them, mostly ice, in fact. And it's that gravitational influence of Saturn's equatorial bulge that makes the ring system so thin. It's only 100 meters thick, and 250,000 kilometers across. It's a very weird shape indeed, a blade-like structure in space. So what we normally think of as gyroscopic forces don't come into play. They're replaced by other forces, basically. So you could almost, if you were some super being watching Saturn tilt on its side and you could see what the rings would do, it would almost look like that they'd follow because of gyroscopic motion, but it's actually because they're being pulled towards the equator, Saturn.
Okay. Yeah. Okay. So it's more gravitational, or...
Yeah, that's right.
Yeah. Okay. Also, he was right. It would happen, but not for the same reasons he's considering. There is an example of it, though, isn't there, with the ring around Uranus, and that is because it's on its side, and the ring around that planet is vertical. Yeah.
Yep. Yeah. So the ring follows the equator of Uranus.
Yeah.
Yep.
Indeed. All right. That spun me out, that one. Thank you, Jacob.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
We have one more question, and this one comes from Nate.
Hey, Fred and Andrew, it's Nate from the Glasshouse Mountains back again with another question. This one's a 3-parter, but it's an opinion piece for Professor Watson. So the first one is, which part of the electromagnetic spectrum, so like infrared, visible, ultraviolet, et cetera, did you find most interesting to kind of analyze and work with in your professional career? And then the second and third might get you into some hot water with some of your colleagues, because I want you to pick one specific part. But which part of the electromagnetic spectrum do you think has contributed most significantly to scientific discoveries thus far? And then lastly, which part do you think will contribute most to science, astronomy, and physics going forward? Thanks, guys. Love the podcast.
Wow, that's a different question. That's really out of left field.
I think it's one of the best questions we've had, is that? It's a great.
Wow. Good call.
Yep. No, I like that one very much. So
well done, mate. Yes, all right. Most interesting EM spectrum is, I think, the first part of his question.
So I have to say, all my comments from here onwards are going to be biased by the fact that my career has been spent in the optical spectrum, with a few wanderings or meanderings into the infrared, which is the redder than red part of the optical spectrum. But the technology that astronomers use, certainly in the past, tended to limit them to having expertise in just one type of astronomy. So you've got radio astronomers, you've got X-ray astronomers, you've got gamma ray astronomers, and all the rest of it, microwave astronomers. Now, we have access to all parts of the electromagnetic spectrum. The bit I know best is visible light, the optical spectrum, but it is also, and I'm not just saying this because I worked in it, it's the best bit as well, for 2 reasons. One is that the optical spectrum is very, very rich in the chemical signatures of atoms. So if you want to find out, where the hydrogen is in the universe, I should perhaps let me pick another example: oxygen rather than hydrogen, or sodium. I'll get back to hydrogen in a minute. All of those things, they emit their light in the optical spectrum when they get excited, as do most atoms. Actually, you get an optical spectrum of the light. So that's why, for example, we see those characteristic orange-yellow streetlights, which were they're out of fashion now, but they were formed by glowing sodium. So that's telling us that there's sodium there because of the specific colours that you've got in that. And likewise, throughout the whole optical spectrum, there's the signature of pretty well all the elements in there. Now, when it comes to molecules, signatures of molecules tend to be more in the infrared spectrum because molecules come together in cooler environments than the atmosphere of a star. Some stars are cool enough that you can form some molecules there. Titanium oxide is one of them. But if you want to analyse molecules, you go to the infrared. But for the elements themselves, and that's the most important bit really, the chemical elements, you've got to go to the optical spectrum. Now, the next bit of Nate's question, if I remember rightly, was what part of the spectrum do you think has made the biggest contribution?
Yeah.
To that, and I'm going to split here into 2 because it's certainly true that without optical spectroscopy, we wouldn't have known about the chemistry of stars at all. And it was the first person who turned a spectroscope to analyse the light of the coming from the stars, a man called William Huggins back in the 1860s, if I remember rightly. He observed the stars with a spectroscope and realised that the chemical elements in the stars had the same signature as chemical elements here on Earth. So he was the person who was able to say, we know what the stars are made of. And that was the birth of astrophysics. So that clearly is of paramount importance. But I nominate a second one.
Let me guess. The indigo bit.
The indigo bit's gone. It's not real.
No. Damn.
It used to be Roigbiv, didn't it? The Richard of York gained battles in vain. Red, orange, yellow, green, blue, indigo, violet. Except right. Indigo was something put in so that you could make it sound all right. It's not really there. No. It goes red, so it's 6 spectrum colours rather than 7. I'm sure people chose 7 just because 7's a sort of magic number with days of the week and all the rest of it. Anyway, exactly. That's another story. I'd nominate, and I perhaps would nominate this as being the one that's going to be most important in the future as well. And that is the 22 centimetre line of hydrogen. Okay. By that, what I mean is it's a signal that has a specific wavelength, 22 centimetres, 1420 megahertz, if I remember rightly. Most radio astronomers think in frequencies rather than wavelength. But that is a feature in the radio spectrum that is produced by cold hydrogen. So you don't need hydrogen to be excited by stars. You just need it to be sitting there in space, cold. What you get is this signal that emits at the wavelength of 22 centimeters. It's in the near radio spectrum, the short wavelengths radio spectrum. And that has allowed us to map the gas in the universe, the cold gas in the universe, and in particular our Milky Way. We know about the spiral structure of the Milky Way because we can trace the cold hydrogen in it, which lies along the spiral arms. The reason why I'm pointing it as being something important for the future is that the Square Kilometre Array, the biggest telescope in the world, that was Geordie agreeing with me.
Yeah, I heard him.
Yeah. Actually, remind me to tell you some other news about pets in a minute. But yeah, the reason why it's important for the future is that the Square Kilometre Array is basically built so that it can look at that wavelength at different redshifts. In other words, see it as it was emitted before the first stars formed. So you can look back in time to when the early universe was just filled with with cold hydrogen that wasn't glowing. And that hydrogen can be traced by this 22 centimetre line. So we can map it. We'll be able to map the hydrogen in the universe before the first stars formed, which is going to be quite extraordinry. So, a great question from Nate there, and interesting answers as well, I think.
Yeah. I think you covered everything for him. In fact, that last answer covered the 2 parts of the second half of the question. So that's really good. Of course, I know what prompted Nate to ask this question. He's in the Glass House Mountains, so on a sunny day, they do see a lot of spectrums.
Yeah, it's a really interesting landscape up there in Glass House Mountains.
It is, isn't it? Yeah. Very. Driving through it, you go, this just doesn't look right. Something weird going on here. Yeah, they're quite striking mountains, they are. You said you had some information about
just
pets.
A little bit of news. Yes, yesterday. So yesterday was my last day at Industry House in Canberra. But sadly, it was also Muscat's last day on Earth because he passed away yesterday. He's been suffering from kidney failure and he'd reached the end of the road. So it was a very sad day on a double count there. So, the house feels very, very empty at the moment without more Muscat pottering around.
That must have been Geordie crying.
Yeah, Geordie, I think Geordie's noticed, that his little chum isn't there. They didn't have the best of relationships, but they kind of tolerated one another.
Yeah, well, that's generally how it goes in most households, even between husbands and wives, I think. But anyway, that's another story. I'm sorry to hear about Muscat.
Yeah, it's sad news, yeah.
Indeed. Thank you, Nate. Thank you, Jacob, Binny, and Seth for contributing. Don't forget, if you would like to send us questions, you can do that on our website. Just go to spacenutspodcast.com or spacenuts.io. If you click on the AMA tab or the AMA link at the top, it will give you an option to send a text question, or you can, if you've got a device with a microphone, hit the start recording button and you'll be able to record a question. Don't forget to tell us in either case who you are and where you're from. And while I'm at it, if you are listening to us on whatever podcast platform, please leave a review. They always help. I don't know how, I don't know why, but apparently they do. Thank you, Fred, as always. Great to talk.
We'll talk again soon, I hope. Great.
I think, that's a good idea. Let's do that.
Yep, let's do it.
I was just going to not do it again. But yeah, I think we should. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio for being there and not here. And from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.